This is the solution video for the mock exam for rotations and matrices. First thing you're going to do is highlight, and when you highlight this exam, notice that first of all the calculator is permitted, and that full or partial credit will be given only when you show the appropriate work. Okay. Also, if you're not giving an answer exactly, make sure you give at least 3 significant figures. And finally, if a solution is not defined, then you say undefined and you explain why. Okay? All right. Oops. Okay, first problem. If G is this matrix and H is this matrix, what is G minus H? So we're going to do the first matrix, -6. Oh my God, look at this. Let's make the pen there. Okay. All right. 5, 6, -6, -3, minus -2, 4, -6, -6. One thing that's tricky about this is that since there's the negative sign here and there's negative signs here, it's sometimes hard to remember that you need to take the negative of a negative, which is positive, right? So let's be careful. We're going to talk it through, okay? So we're going to take 5 and we're going to subtract -2. So that's 5 plus 2, which is going to be 7. We're going to take 6. We're going to minus 4, so that's going to be 2. -6 minus a -6, so it's -6 plus 6, which is 0. -3 minus a -6, so that would be -3 plus 6, which is 3. And that's our answer. So basically what we did was we took each corresponding number, like 5 and -2, like -6 and 5 minus -2, -6 minus a -6, and we just subtracted the corresponding numbers to get the result. You see we get the same size matrix. This is 2 by 2, this is 2 by 2, and finally the result is 2 by 2. Okay, number 2. Okay, then it says you have this matrix, and you have this matrix, and it says what are these two matrices added together? Well, we just said that to subtract matrices, you need to have two matrices that are the same size. Are these matrices the same size? No, they're not. This one has 4 rows and 2 columns. This one has 1 row and 4 columns. You cannot add or subtract these matrices. So you say it's undefined. And you say because to add matrices, they need same number of rows and columns. Okay. Number 3. Now this is similar to the one we did before, except now we have this number here, 7 in front, and this is called a scalar multiplication. When you do a scalar multiplication, you have an ordinary number, not a number in a matrix, sitting outside of a matrix, and what this does is it means that the 7 is going to be multiplied times every single element of this matrix, and you're going to end up with an identical sized matrix with this multiplication done. So let's see. So first I can do 7 times 8, which is 56. 7 times 9, which is 63. 7 times 5, which is 35. 7 times 2, which is 14. 7 times 5, which is 35. And 7 times 3, which is 21. Then I'm going to subtract this other matrix. And I'm going to get an identical sized matrix. I'm going to get another 3 by 2 matrix. Okay, so let's talk this through. 56 minus 2 is 54. 63 minus 8 is 55. 35 minus 5 is 30. 14 minus 0 is 14. 35 minus a -3 is 35 plus 3, which is 38. And 21 minus a negative 5 is 21 plus 5, which is 26. Okay. Next one. Ooh, this is a matrix multiplication, and it's a big one. If you're more comfortable arranging it like the suggested arrangement so that you can see what you multiply together more easily, I strongly suggest that you go ahead and make that rearrangement. Okay. So we got the first matrix on the left, we got the second matrix on top, and we're going to multiply this times this in order to get this number here. So it's going to be 1 times 0 is 0, negative 2 times 3 is negative 6, and 0 times 0 is 0. So we got negative 6 for this one. Okay. Then we're going to do the first row here times the second column here. 1 times 1 is 1, and the rest of them are 0, so we just put 1 here. You see what we're doing here. We're doing 1 times 1 is plus negative 2 times 0 plus 0 times 0. Okay, so we took the elements here and we multiplied that times the elements here. The corresponding elements, the first times the first, the second times the second, third times the third, we add them all together, and that gives us that 1 right there. Okay? Now we're going to do this row times this last column. 1 times 0 is 0. Negative 2 times 3 is negative 6. 0 times 3 is 0. So we got negative 6 for this one too. Now we're going to do the second row times the first column. So it's going to be 1 times 0 is 0. Negative 2 times 3 is negative 6. 0 times 0 is 0. A lot of negative 6's here. Now we're going to do the middle row times the second column. So 1 times 1 is 1. Negative 2 times 0 is 0. 0 times 0 is 0. So 1 times 1 is 1. It just goes there. Now I'm going to do 1, negative 2, 0, and I'm going to multiply times 0, 3, 3. So 1 times 0 is 0, negative 2 times 3 is negative 6, and 0 times 3 is 0. Last column, 0, negative 2, 2 times 0, 3, 0. So that's going to give us 0 times 0, negative 2 times 3 is negative 6, and 2 times 0, which is 0. So it's going to be negative 6 again. Okay. Third row times second column. So it's going to be 0 times 1 is 0. Negative 2 times 0 is 0. 2 times 0 is 0. So it's going to be 0. Last column times the last row times the last column. So 0 times 0 is 0. Negative 2 times 3 is negative 6. 2 times 3 is positive 6. Negative 6 plus 6 is 0. All right. Okay, so that's the answer. This is the resulting matrix. Okay, now here is a smaller matrix multiplication. I advise you to do the same thing. Even though it's small, it can be tricky. If I arrange it the same way as I did before, it's painfully obvious that this is going to be a 2 by 2 matrix as the answer, right? Otherwise, you might get confused and think it's a 1 by 1 matrix. This is going to be a 2 by 2 matrix. So, I'm going to first take this times this, and you can see that it's just going to be a single number times a single number, which is quite an easy matrix multiplication. Then I'm going to do 1 times 1, it's 1. Negative 2 times 2 is negative 4. Negative 2 times 1 is negative 2. So that was quite an easy one, wasn't it? The only trick is to make sure that you are multiplying and getting a 2 by 2 matrix as the result. Write an example of a row matrix. Actually, there are examples of row and column matrices right here. A row matrix would be like this matrix here. What about this matrix? This matrix, of course, is called a column matrix. So a row matrix looks like just one row. Write an example of an identity matrix, then demonstrate a multiplication of that identity matrix with another matrix of your creation. Identity matrix, first of all, is a square matrix. It's going to have the same number of rows and columns. And Along the diagonal from the top left to the bottom right is a string of ones diagonally, and all the other elements are 0, like that. Now you could put any matrix here that is has a number of rows of 3, right? Because this is a 3 by 3 identity matrix. If I put 3 by 1 or 3 by 2 or 3 by 3, those are fine because the middle numbers match up, which is necessary, okay? So I'm going to put a 3 by 3 matrix here. I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9. If I multiply the identity matrix times this matrix, the identity matrix times any matrix always gives you the same matrix back. If you're not sure about it, go ahead and multiply out the identity matrix times the new matrix and see if you get it. You should get the exact same matrix again, no matter if you multiply the identity matrix first times the matrix you created or in the reverse order. Okay, so like for example, if this is the matrix I for identity matrix, this is the matrix A for the matrix A, you can put I times A, and that's going to equal to A. And you can also put A times I, and that's also going to equal A. Alright, number 8. Write an example of a 0 matrix, then demonstrate a multiplication of that 0 matrix with another matrix of your creation. So I'm going to make a 0 matrix, and then I'm going to multiply that times maybe a row matrix like that. And this is going to give me a row matrix, which is just zeros. Okay? All right. The point 1 comma 0 is rotated 60 degrees, negative 60 degrees. What are its new coordinates? Okay, so if I have 1 comma 0, it's right there. If I rotate it negative 60 degrees, it's going to go in the clockwise direction. It's going to end up here. What are the new coordinates? Well, from our investigation, we know that the coordinates of these points here are all 0.866 or 0.5. We just need to figure out if it's negative or positive. So like this triangle here, oops, that's like way too thick. But if we look closely at this triangle here, we know that this long side is 0.866, and we know the short side is 0.5, and we know that the 0.866 is positive because it's going to the right. We know that the 0.5 is negative because it's going down, right? So we can put here that the new coordinates of, oh, I'm sorry, it says it rotated negative 60 degrees, not negative 30 degrees. So actually it didn't go here. It went all the way down to here. So let me take that back. It actually went 0.5 over and negative 0.866 down, right? Because it went 60 degrees, not 30 degrees. So the new coordinates are going to be positive 0.5, comma, negative 0.866. All right. Finally, rotational matrix general form is this formula. Find the rotation matrix that when multiplied times a column matrix of coordinates will rotate it by negative 30 degrees. Okay, so this is similar to the work we did on the last investigation. So if you have a certain coordinate pair like 1, 0 or something here, and if you multiply this rotational matrix times the original matrix, you're going to get a new matrix where the new coordinates are rotated by the angle theta. And in this case, we want to know, in the case of negative 30. Okay? So basically, we know that if we put in negative 30 in for thetas here, we're going to be able to find the matrix. Okay? So we're going to have cosine of negative 30 degrees, sine of negative 30 degrees, negative sine of negative 30 degrees. That's weird. Negative of negative. Cosine of negative 30 degrees. Okay, and we are going to use our calculator to do this. Why not? Let me just make this smaller. Okay, Now I'm going to use the calculator here and make sure I'm in degree mode, especially when you're using this calculator on your computer. If you're not careful, you turned it off and you need to put it back in degree mode. So first I'm going to say, okay, what is the cosine of 30, or negative 30, I'm sorry. Not subtract 30, it has to be negative 30. And the answer is 0.866. Oh, that looks familiar, doesn't it? Our old friend, 0.866. Okay, so that means that this is also 0.866 because the diagonals are the same. Then we're going to find out what is the sine of negative 30. So you notice when you take the cosine of 30, you actually get the same number as cosine of negative 30. So sine of negative 30 is negative 0.5. So this one is going to be negative 0.5, and then negative sine of negative 30 is going to be negative 0.5, which is going to be positive 0.5. Okay, so that's the rotational matrix that you use to rotate by negative 30 degrees. Last one, there's a 2 by 2 rotational matrix A. The element A1, 2, and 1, 2 means row 1, column 2, is negative 0.2. Find the element A21, and what rotation will this matrix perform when multiplied times the column matrix of coordinates x and y? So if we put that row 1, column 2 element is negative 0.2, that would be row 1, column 2, so that would be negative 0.2 here. And then we don't know what the others are yet. It says to find the element 2,1. 2,1 is this element here. Now we do know from looking at this form of the rotational matrix general form that look, negative sine theta here, sine theta here. So if it's a rotational matrix, this element is the opposite in sign of this element. So if this is negative 0.2, this must be positive 0.2. Okay, so we can fill that in. And then we don't even need to figure out the rest, because now what they ask us is what rotation will this matrix perform when multiplied times a column matrix of blah, blah, blah. We can figure that out just from the fact that the sine of theta is equal to 0.2, right? Now this is like from last chapter, but we can figure out theta if we know that sine of theta is 0.2, right? We could take the inverse sine of both sides, and that'll give us an angle. So we're going to do second sine 0.2, and we get 11.5 degrees. Okay? 11.5 degrees. All right. And if you want to find the other corners of this matrix, all you need to do is find the cosine of 11.5 degrees, which is 0.97 or 980. Okay. All right, but you don't need to do that because it doesn't say to find the matrix. It just says to figure out the rotation. All right, and that's it for the core.